So we are going to cover that part. Mm, Under forecasting techniques, there are a lot of forecasting techniques with a lot of statistical techniques used to forecast because all of our present activities uh, in business environment depends on forecasting. Forecasting means we predict about future demand and future conditions, all those things. So forecasting is very important thing. So there are a lot of forecasting techniques, but here in this module we discuss two things: linear regression analysis and basic time series analysis. Now in the topic it says introduction to time series analysis, so it will be very basic things. Can you see this slide?
Yes, sir.
Okay, so we do these two topics today: linear regression analysis and introduction to time series analysis. So sometimes you may have studied these things earlier, especially regression analysis, but we will do it from the beginning. So anyone is telling something, I can see somebody's mics are working, but I cannot hear anything. So can you hear me? Okay, so if not, we'll continue. Okay, so regression analysis. Uh, Regression analysis is used to study the relationship between variables. So you can read the slide. Regression analysis is used to find out the relationship between variables. Now, when we take two variables, there are many kinds of relationship between those two variables. Uh, Sometimes there can be positive relationships. Now, positive relationship means if the value of one variable increase, the value of the other variable also increase. So that is called the positive relationship. There can be negative relationships also. Negative relationship means if the value of one variable increase, the value of the other variable decrease. Now, for example, if we assume that if the price of some item is increased, we can observe that demand can be decreased. So there will be a negative relationship between those two. When one increase, the other variable decrease. So that is called a negative relationship. So positive relationships are there, negative relationships are there. Also, there can be variables where there are no relationships between those variables at all. No relationships. So those are the basic relationships that we can identify between variables. So we want to quantify that relationship. So based on that relationship, we should be able to predict about future. So that is why we study the regression analysis here. So regression analysis is used to study the relationship between variables. Okay. In the first bullet, it says in this course, simple linear regression is considered. Simple linear regression. The simple linear regression model shows the relationship between two variables. independent variable and dependent variable. Okay, so we consider here simple linear regression. Now, simple regression means there are two variables, one independent variable and one dependent variable. So there are cases that we study the relationship between more than one variable. So one independent variable and many dependent variables. So those are not simple. So when we say simple regression, you should know that we study the relationship between two variables. So otherwise it is called multiple regression models. So we are not going to study the multiple regression models here. So we study simple regression models. Then it says simple linear regression. So linear, you know that linear means it's a straight line relationship. Okay, so we study the regression analysis here under two conditions, simple and linear. In the case of single dependent variable and multiple independent variables, multiple regression analysis is used. So that is what I explained. When there are more than one variable, we called it multiple regression analysis. So here we study the very basic case, that is simple linear regression model. Okay, so I will explain the relationships like this. Now, suppose you have some data sets, say X and Y. So we have some values here. When we plot these values in the graphical plane, let's say X and Y axis, sometimes you can see when we plot here, we can see this type of relationship. We can see this type of relationship. If you cannot see, I will go again. Now here we can see that the value of this variable x increases. We can see an increase of y variable also. Okay, so that means we have this type of increasing relationship. We can see this one is increasing. Therefore, we called it positive relationship. We call it positive relationship. Now, sometimes there are situations when we plot, now we call this a scatter diagram. We call it a scatter diagram. So we just plot the values. Sometimes when we plot, we will see when we plot, we can see this type of relationship. So when the value of variable x increases, we can see that the value of variable y decreases. So this type of relationship. So we can see a decreasing relationship here. So we call it negative relationship. We call it negative relationship. Also, there are situations when we plot, we cannot identify any type of relationship. Now, these values are everywhere. We cannot identify any kind of positive or negative relationship from here. So, this is the situation. There are no relationship. This is the situation. There are no relationship. So, when we have this type of relationship based on this diagram, or based on this regression analysis techniques, we can find the future values. So, these we know these previous values or current values. Based on this one, we can find the future values. So this is the objective of this regression analysis. We study the relationship between variables, then we try to forecast using the relationship that we have found. So that is the regression analysis. Okay, then okay, now here what we want to do is that based on this relationship, we want to find the relationship. So here, if you look at this one, this graph, you can see that there's a positive relationship, but when the relationship is in this way, we cannot use it for forecasting. So what we can do is that we can draw a line to represent all these points. We can draw a line to represent all these points. So when we draw a line, uh, we want to cut as much as possible these points. But if we try to cut all the points, you can see that we cannot draw a straight line because these plots are not in a line. So we cannot draw a line to cut all these points. But we can draw a line to reasonably represent all the points. We can draw a line to reasonably represent all the points. That is not exact, but we can just draw a line to represent all the points reasonably. So that is called the regression line. So that is called the regression line. Before we proceed further, I think you can draw these figures, the types of relationships. Then I will explain how to draw the line and estimate the equation of the line and then uh, find the relationship mathematically. We just draw these three graphs that will show the relationships between two variables, positive relationships, negative relationships, and uh, the case where there is no relationship between the variables. Okay, now those are the possible relationships. Uh, in this lesson, we want to mathematically find that relationship. So that is the objective here. Now, look at this graph. Now, if I can draw a straight line to represent all the points, what we can do is we can find the equation of that straight line. Based on the equation, we can do the forecasting. So that is the objective. Now, the thing is that if I try to draw a straight line to cut all these points, that is impossible because these points are here and they are not in a straight line. So I cannot draw a single straight line to cut all the points. The reason is that these points are everywhere, not in a straight line. So what I can do is I can draw a line to reasonably represent all the points. So that means you can see that if I take this point for example, actually this line does not represent this point. Actually this line does not represent this point. There is a deviation. Okay, so if I mark here, there is a deviation. So this is the deviation. This is the deviation. Now this is the actual, this is the actual point. But if we draw a line here, this is not the actual point. There is a deviation between the actual point and the point on this line. Okay. Now, someone can draw the line from here. Someone can draw the line from here. Somebody can draw the line from here. That depends. But if you want to maintain the accuracy, you want to draw the line to minimize all these deviations. You want to draw the line to minimize all these deviations. So that is the technique here. So what we can do is we can draw that line to minimize the deviation. So in other words, we call that is an error. So this is the error. The actual value is here, but when we draw the line and find the value, this is different from this value. So that means there is an error because we are going to estimate these values. We cannot represent all the points. We just draw a line to reasonably represent all the points. So reasonably represent means we cannot do exactly, but we want to minimize the deviation. Okay. So what we can do is that once we draw this line, we know that the equation of this line is y is equal to mx plus c. Y is equal to mx plus c. So if we find the relationship, for example, let's say we will find this relationship y is equal to 2x plus 5. This is the relationship for example. Then if you want to find any future values, what you can do is you can substitute for this x variable, then you can find the y value. So this is the technique here. But here we do not write y is equal to mx plus c. We write the equation of the regression line. Y is equal to b naught plus b1x. B naught plus b1x. So this is similar to y is equal to mx plus c. So this m is for b1 because here b1x, mx, and b naught represent this c. So here from this graph you can see this is the b naught. So here I have represented it as beta naught, and this is the gradient of the line. Beta 1 is gradient of the line. Now if we know these things, we can find. So the next question is that how to find this b naught and this b1. So we can draw this line to represent all the points. Uh, to find the equation, we want to find this B naught and B1. The question is how to find this B naught and B1. So there is a method to do that. It is called the least square method. So I am not going to explain the least square method here because the least square method is to make sure that we draw this line to minimize the square of these errors. So it is a little bit advanced here. So therefore I am not going to discuss here. But if you search for internet and see least square method, you will see that we want to minimize the square of these errors. We want to minimize the square. So we take the square because there is a reason to take the square that we will discuss if we had enough time. But for the time being, I want you to note down these two, B1 and B naught, just B1 and B naught. Then I will explain by example what is the relationship between what I have explained here and this one. So everything in this slide you have to write down. This B1 formula, B naught formula, and these things please write down. You may not understand as it is, but I will take one example and explain this one. Okay, so please write down the content in this slide. Okay. Write down this example also. Okay. So if it is finished and you do this small exercise. This x-axis and y-axis. Can you roughly plot these values and tell me what is the relationship? Whether it is a positive relationship or negative relationship or there are no relationship. Just plot. For example, the first coordinate is 1, 7. So there are coordinates 1, 7, 2, 8, 3, 9, 4, 8, 4, 8. So no need to draw it in exactly a correct scale. Just roughly plot and tell me what is the relationship here. For example, we can roughly mark 1, 2, 3, 4, etc. We can mark here. Here also value start from 7. So I will start from 5, 6, 7, 8, and so on. So first coordinate is 1, 7. So I can mark it 1, 7. Then 2, 8. Likewise, you can mark. Now mark all the points and tell me what is the relationship. Now please do it quickly and tell me what is the relationship between these two variables x and y. So don't take much time, quickly do it and tell me what is the relationship. Just draw it quickly and tell me what is the relationship. I just received one answer. So what about others? What is the relationship?
तो तुम्हारे बात में अपना हाथ पर
Okay, so most of you have found it that it is a positive relationship. So positive relationship means you can observe it from here also. When the value of x variable increases, you can see that there is a similar increasing value of variable y. Now the question is, if somebody asks you this question, what is y when x is equal to 10? For example, if this question is asked, we should be able to answer this question uh, using these values. Now these are historical values. So we have x values from 1 to 7, and there are corresponding y values also. Then somebody asked this question, what is y when x is 10? We should be able to answer this question based on these values. So that is why we need regression analysis here. So what we do is that we will mathematically estimate the relationship between x and y. We will mathematically estimate the relationship between x and y. Based on that, we can find. Now here we say, in the question it says estimate the linear regression equation for the data given below. Estimate the simple linear regression. So we study the linear relationship, but sometimes there are non-linear relationships also. So you can see that if you, for example, when you plot the data, you will sometimes see this type of relationship, but it can be in this way. It is not a linear relationship. It is a non-linear relationship. Now here we are not going to study this non-linear relationship. We study only the linear relationship. That means the relationship is in straight line form. The relationship is in straight line form. So if you want to answer this question, you have to estimate the relationship between these two. So that is y is equal to b naught plus b1x. Y is equal to b naught plus b1x. So we want to find these two parameters, b naught and b1. We want to find these two parameters. To find these two parameters, I have given you some formula. The derivation of this formula is not discussed here. You can just refer to web. So you can search in the Google how to derive regression parameters. Then you will find the details. So if anyone interested, and if anybody do not understand that, if you contact me, I will explain how to do that. So I am not going to do it here. So the formulas are given. So how to find B1, how to find B naught. So this is the B1 formula, this is B naught formula. So in this B1 formula, you can see that the sigma xy is here. I will explain that. Then x bar and y bar here, and x square, sigma x square is here. Okay, so x bar and y bar, I think you know that x bar means the mean or average. Okay, so average of x. Y bar is the average of y. So average of x you can find. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 data. So you can take the sum of these values and divide it by 10. You will get x bar. Now similarly, you can find y bar also. So take the sum of these values and divide it by 10. You will get y bar. So how to find the other things? It is better if you can extend this table. Now, for example, let's say we have x value and y value here. Then you need xy, and you need x square. Then you have this x values 1, 7, 2, 8, like that. You have these values. Then xy you can find. Xy means product of these two. 7 into 1, 7. 8 into 2, 16. Similarly, you can find it for all the values. Then x squares are also there. X is 1, so x square is 1. X is 2, x square is 4. Likewise, you can find. Then at the end, if you take the sum of these values, if you take the sum of these values, this is sigma xy. If you take the sum of these values, this is sigma xy. And if you take the sum of these values, this is sigma x square. This is sigma x square. Then sigma xy you can substitute here. Sigma x square you can substitute here. Then x bar and y bar no problem we can find. X bar square also we can find. So you can find B1 without any problem. If you apply this formula and use the values of this table, you can find it. Then once you find B1, you have to use that to find B naught, because this B naught formula, you can see that the B1 is here. Therefore, the first value you have to find is B1. You cannot find B naught without B1. So first find B1, then use this value to find B naught. Uh, what I want you to do is now, can you complete this table first now? Please complete this table. Then we can find this B1 and B naught value, and we can substitute values here and estimate the equation. Now quickly complete this table, then we will go ahead. Now remember, you have to first find x bar and y bar. Okay, so did anyone find this x bar value? Now take the sum of these x values and divide it by number of data. So what is x bar value? Anyone found that? Can someone 4.3? 1, 2, 3 is 43, therefore it's 4.3. Y bar value?
10.2.
Okay, so it looks correct. Then please complete this table. I want you to find this value and also this value because in the formula we have to enter those two values. Okay, now look at this. These are the values that I get. Please check whether these values are correct or not. Now this one is sigma xy, and this one is sigma x square, sigma xy and sigma x square. And we know that x bar is 4.3 and y bar is 10.2. And the number of data here is simple length, that is 10. So we have 10 pairs of data here. Now from the formula we can find. So let's say this B1 formula is sigma xy minus n x bar y bar. So I'm referring to this formula. So you can write down this formula and substitute value sigma xy. Sigma xy means 476 minus 10 times x bar y bar. So that means 10, 4.3 into 10.2 divided by sigma x square. So that means 217 minus n means 10. X bar square means 4.3 square. Okay, so you can find the value. It's 476. Now please calculate this value. At 1.16, can somebody calculate this? I got one answer 1.1165, but I'm not sure. Please check the correct value here, because the value of B naught depend on this value. Because we have to accurately find this value first. Can someone check and verify me whether this 1.16 is correct or the value is different?
Correct, sir.
1.165.
1.165.
Okay, sir.
Okay, 1.165. So we'll take it to two decimal points. So it is 1.16. Then we want to find B naught. Now B naught, you can use this formula. B naught is equal to y bar, that means 10.2 minus B1 times x bar. So B1 means 1.16 multiplied by 4.3. So it's approximately 5.2. It's approximately 5.2. Then our equation is y is equal to b naught plus b1x. So we can write, therefore y is equal to b naught means 5.2 plus b1 1.16x. Okay, so this is the mathematical relationship between these two formula, but it is not the exact relationship. This is the best relationship that we can find. This is the best relationship because when we draw the line to represent all the plots, we draw the line of best fit. That means we try to minimize the deviations. Okay, that is the way we are drawing the line. If we draw the line in that way, we get the best estimation of the equation of the line like this 5.2 plus 1.16. Now, this equation also represent that there is a positive relationship because we get a positive value for B1. If we get a negative value for B1, that indicates that the relationship is negative. Okay. Now, based on this equation, we can find the values outside this range. Now, for example, when x is equal to 10, can someone find the value of y?
16.8.
So it should be 5.2 plus 1.16 into 10. 16.8. So, so this is the procedure. Now we get the data set. Then we estimated the line of best fit, and using this equation, we can find the values of y for the values of x outside this range. Now, if we do something like that, for example, let's say mm, for x equals 3, what is the value of y? Can someone quickly calculate and tell me what is the value of y when x is equal to 3?
Eight 8.68.
That is 8.68. But when you look at the original data, you can see that when x is equal to 3, y is 9. But when we calculate using this formula, we got 8.68. So what is the reason for this difference? What is the indication? Is our calculation wrong, or is there any other reason? What is the reason for this difference? Anything wrong with our calculation, or are there any different reason for this? Any idea? The actual data, the y value corresponding to x is equal to 3 is 9, but when we calculate using the equation, we got 8.68. Now there is a difference. So what is the reason for difference? Is our equation is wrong, or is there any other reason for this difference? Any idea?
मीन निकाल कैलकुलेट करना है ना.
Okay, now look at this graph. When we draw this line does not represent all these plots. Okay? This is only estimation. It does not mean that this equation satisfy all these plots here. So when we draw the line, we can cut some plots but not all the plots. Okay, in that case, there will be a difference between the actual value and the calculated value. So it's not anything wrong with our calculation. That is the error associated with this equation. There is always an error because from this one also we can see that this is not a straight line exactly, because for the same value of x we can see different values of y. So that means this is not a straight line, but we calculated the equation of a straight line. That means modeled modeled this data as a straight line. So there is an obvious error. That is the error associated with this estimation. So the actual value is 9. We got the estimated value is 8.68. But we estimated B1 and B naught to minimize this error. Okay, so that is the theory behind this estimation. We minimize this error. So for this any value, there can be an associated error. It is okay because we do just an estimation. From the forecasting also, we find estimated the forecasting. We estimate. We don't know whether it will be happened actually or not. It is only an estimation. Therefore, we cannot do it 100% correctly. There is always deviation. So that error is okay. So you can explain that error because this is an estimated value. Uh, because these values does not actually represent the straight line, but we model this as a straight line. Therefore, there can be some error. So that is the error difference between 8.68 and 9. Okay? In that way, you can explain that. Okay, so we see one more example. Okay, now draw this table and just do this part A. Construct a scatter diagram to identify the relationship between X and Y. Just construct the scatter diagram and tell me what is the relationship between these two variables. Then later we can do this one. No need to complete the table. Now you can do that. Just draw the scatter diagram and tell me the relationship. We draw the scatter diagram and find out the relationship, whether it is a positive or negative. Okay, so I got some answer. It says that it's a negative relationship. Yes, it's a negative relationship. You can see that when x is equal to 2, it is 87, and it becomes 5, 64. That means reduce. For 9, it's 71. And for 6, it is 56, further reduce. There are some special cases, 9 to 71 small increment, but in general, we can say that when x increases, the value of y will be decreasing. Therefore, it is a negative relationship. Now, when you complete this table and find the equation, you will see that you get a negative value for B1. You will get a negative value for B1 parameter. So that indicates that the relationship is negative. Okay, so that is about the estimating regression line and make forecasting using the values outside the range of x. Okay, so you can first identify the relationship, then uh, estimate the regression equation, then you can substitute values for the x variable and find the corresponding y variable for the values outside the given data set. So that is the process. Okay, so with that, we will move to the time series section. Actually, we are not going to discuss details of this one because related to the building services technology area, the application of time series is very less because uh, the time series means that when we talk about two variable, one variable is always time. Okay, so you can see that in dataset there are two pairs. The years are given here. The values corresponding to these years are given. So you can see that we can take this variable as x variable. The x variable is always time. For example, when we say, uh, let's say annual rainfall, when we say annual, we know that the one variable is time. So we can collect the data of yearly rainfall, and that is called a time series because the one variable is always time. Okay. So when we take the time series, when we get the data and make the plot, there are different components. There are different components. So if I explain like this, you may not understand. These are the components of a time series: trend, cyclical fluctuations, and seasonal variation. So if I explain by a graph, you will understand. So here you can see that in this time series, this time and these are the values of a variable. So in this plot, you can see that there is an increasing trend. So this is the long-term trend. Long-term trend is increasing pattern. It can be decreasing also. In the time series models, you can see that when we plot the data, sometimes some cyclical fluctuations are there. So it goes up and down, but in a cyclical form. So it says cyclical fluctuations. And sometimes you can see that you can see some seasonal variations. So for example, you can see that these are the time periods. At the end of each time period, you can see that the values are decreasing. Here the value is decreasing, here the values are decreasing. So we can say that in this season, the value of this particular variable is decreasing. So those are called the seasonal variations. So the middle of the year, for example, let's say these are years. In the middle of the years, you can see that the values are decreasing. So in that season, values are increasing. So those are called the seasonal variation. So the trend patterns, then cyclical fluctuations and seasonal variations are there in time series data. If you cannot explain any behavior using these three components, we will say that it is random or unpredictable variation. So you don't have to think too much about these things. Since this topic is included in the syllabus, we will discuss about this long-term trend calculation. Actually, this is similar to the calculation of regression line, but the only difference is that the x variable is always time. So here for this one, for the time series analysis, at least 15-20 years of data should be used to calculate. Otherwise, we will not get the correct forecasting. Okay. Look at this example. Determine the linear trend equation for the following data. Okay. So when we determine the linear trend equation, we can use exactly the same approach that we used in regression analysis. So we can find B1 and B naught for this data. We can find B1 and B naught for this data, and we can estimate the equation because it says determine the linear trend equation. So it is assumed that there is a linear relationship. Then what we can do is we can make this type of table. X values are there, Y values are there, then X is there, then XY. You can complete the table and you can use these formulas and find the regression equation. From this regression equation, we can find the trend. Trend mean it is the positive or negative value. If it is increasing trend, we know that it is a positive relationship like here. This is an increasing. So that means a positive relationship. So we can find the relationship and we can quantify it using the regression equation. The problem here is that when we talk about years for x variables, there will be a big calculation because the values are 1960, 1961, 1962. So we have to take these values into the account. X is equal to 1960, X is equal to 1961. So the calculation is very complex. To avoid that one, there is a coding system we use here. We can assume 1960 is equal to 1. Okay, therefore, this value we can write this is equal to 1. So this value is equal to 2. This value is equal to 3. Like that, we can use some coding. So x values are then 1, 2, 3, 4, 5, 6. The y values, we have to use the actual values. Okay. Now, if we use this coding system, what is the value for say for example we want to find the y value for 1991. Okay, then for 1991 what is the x value? If you understood what I was explaining, now what we are going to use is that using these x values 1, 2, 3, 4 and these y values, we will find the regression equation. Then somebody want to find the y value when the year is 1991. So if it is 1991, we have to substitute for x value. But x values, we are now using a coding system. 1960 is 1, 1961 is 2, like that. Then what is the value we are going to substitute in the equation if we want to find the y value of 1991?
31.
31.
Yes.
32.
31.
32.
Is it 31 or 32?
32.
32.
Yes, it should be 32. So what you have to do is you can substitute 32, then from the regression equation you will get. Okay, so that is the way you calculate the long-term trend or trend calculation. So trend means we find the relationship is positive or negative. So whatever the relationship, we find the relationship mathematically so that we can substitute values and uh, find the required values in the future. Okay, so that is the way you calculate the trend using the regression model for the time series. Now the time series, what you have to understand is that the one variable is always time. The calculation procedure, there is no difference. We here do only the trend calculation, then the seasonal and cyclical variation calculations are very complex, and also you don't have applications related to those here, because if we consider the demand, for example, usually it is necessary to find the trend. That means whether it is increase in demand or decrease in demand. So it is enough to calculate the trend pattern there, whether it is positive or negative, and then we quantify and we find the relationship mathematically and estimate the future values. Okay, so what I want you to do is now, there are two examples here. The first one, this one we did not complete. So I want you to complete this one. Then also I want you to complete this one. Okay, so when you complete this one, you have to use this coding. If you want, you can take any other value. For 1960, somebody want, you can use 0. You can start from 0 and do. Okay, so here I have used 1. Okay, so what I do after the class is that there are a lot of slides I have not sent to you yet. From the beginning to now, I will send all the slides. So when I send this slide, I want you to complete this example and also this time series example. So there is no difference between this example and the time series example. Only thing is that for the years you have to use that coding system that I have introduced. Then you have to estimate the line and find B0 and B1 value. Okay, so any question about this regression line calculation? If I summarize what we have done from the beginning of this module, we started with the linear programming problems. For the linear programming problems, we studied how to formulate a linear programming problem. When a real world problem is given, we should be able to convert it into a linear programming problem. To do that, we have to identify what are the variables associated And then we have to write the information given in the question in terms of the variable. Then we can formulate the linear programming problem. In the linear programming problems, there are components, objective function, problem constraints, non-negative constraints. I think you remember these things. Then we explain these things and we formulated linear programming problems. Then once the linear programming problems formulated, we should know how to solve. So I have explained how to solve linear programming using Microsoft Excel. There are many other softwares you can search. Even though you do not have any knowledge about linear programming problems, if you get a problem, you can use the software and find the solution. So using Excel, we did that. Then using graphical method also, we did. The graphical method we can apply only for two variables. Then after that, we discussed transportation problem. The transportation problem means there are different origins and different destination. We wanted to find how many units we transport from each origin to each destination in order to minimize the total transportation cost. So under transportation problems, there have been some variations. Balanced transportation problems, then unbalanced transportation problems. Then we know if it is unbalanced transportation problem, we have to first balance the problem by introducing a dummy supplier or dummy customer. So these things we have discussed. Then in the transportation problems, minimization problems and maximization problems as well. So minimize the total transportation cost or maximize the total transportation profit. So we have discussed those two things. Then we move to the assignment problem. The assignment problem, the objective was to assign some jobs to people or jobs to machine in order to minimize the total assignment cost. Uh, Unlike the transportation problem, there is a condition that the one person can undertake only one job and one job can be given to only one person. We cannot split the job and give to different people. One job can be given to one person or one machine. So that is the feature in the assignment problem. So after the assignment problem, we move to the topic inventory management. So I explained what is inventory, why we need to properly manage the inventory. So then in any inventory management problem, we have to answer two questions, how much to order and when to order, but keeping the objective that we want to minimize the total inventory cost. To answer to how much to order, we calculated the economic order quantity or denoted by EOQ under two cases, without shortages and with shortages. When there are shortages, the formula with the backlog will be taken, backlogging, back ordering. I explained what is back ordering. Then after that, we answer to the our second question, that is when to order. So that is given by the reorder point. That is given by the reorder point. And as the last topic, today we discussed the forecasting techniques and the topics in the syllabus. It is given that simple linear regression analysis and introduction to time series analysis. So we have covered that part. I have given a small introduction what the time series is. In the time series, the one variable is always time. Then how to calculate the trend line or the relationship that is done using the regression analysis, regression equation. When we get a set of data, we estimate the line of the equation. Remember that we only estimate, it is not actual one because that line does not cut all the points. Therefore, it is estimation. There is always deviation between actual point and the estimated point. So we calculated the equation in the form of y is equal to mx plus c. For m and c, we use the b1 and b0. Okay, then using the equation, we can find the values other than the given values. So that is the basic idea of simple linear equation analysis. Simple and linear. Simple means there are only two variables. Linear means we calculate the equation in the straight line form. But there are nonlinear cases and also multiple regression models. Okay, so with this, we concluded the module. That so what I have to do is that I have to send you all the lecture slides. Then you have to practice all the examples that we have discussed in the class. Okay, so anything you want to ask? So your final exam will be after some times, because in the faculty we have decided to send B1 student for industrial exposure from the next month, and for B2 students semester 3 will be started. That is the plan. So it will take some time to have the exam. I think before the exam we can have one session and do some exercises uh, to have you some kind of revision there. So that in my last email I explained that I want to have one extra class to do some exercises, so we can have that when the exam is declared. Any question that you have to ask before we finish the class? Okay, so it looks like no questions. So what I have to tell you is that when after I send the notes, you have all the questions there. You have to practice, especially transportation problems and those things. You have to practice, otherwise the time will not be enough to complete the problem in the examination. That is some calculation procedure. You have to practice this. When you do 10-20 questions, you will find that it is very easier and you will quickly do that. Okay, so I will stop the class for today. So if you have any question when you do the exercises, you can just send me an email. Then I will help you to complete that. Okay, so we'll stop the class.
Thank you, sir.